things, this is not a new topic for all of you. So the project that we have, Adam, is going to be a 4,000 amp switch gear. We will have 200 amp panels and 400 amp panels and what's not. Um, I know you guys, we did the residential project, the commercial project, and this is the industrial. Panels can go from 225 amp all the way to 1200 amps. I'll show you standards that Collar Hammer does. The panel type, we'll talk about circuit breaker versus fuse switch panel type. Selective circuit breakers, guys, to protect the panel. Like we said before, Derek, every panel must have a circuit breaker to protect it. So if your panel is 200 amp, you need a 200 amp or less to protect that 200 amp panel. Make feeder connection to the panel board. There is sub feed and feed through, and I don't know if you guys remember, it has been a while when Collar Hammer speaker came and he talked about sub feed and feed through. I'll show you a couple of examples on that. What do the panel do for living, guys? They do two things. When you have a panel, you guys have done it. First, they control. Second, they protect all the circuits and deliver the power to the devices. So they deliver, and here's the panel. It's like a busway. The panel, what does it do? Deliver the power to the system, to you, if you're a load, and the lights. And in the process, it controls it, so you can turn them on and off through a circuit breaker if you want to, and protect them from short circuit. Deliver power, control, and protect. Does that make sense? That's what panels do, like a busway, exactly like a busway do. Distribute the electrical energy from the source and the supply outlet throughout the building. So distribute the electrical energy and the supply outlets throughout the building. So deliver energy, like I said, all the way to all these consuming devices. That's the role of the panel. The project that we have, Karen, right here, the commercial project, by the way, we have two projects, one in the book and one you guys Revit one. The book one has close to 15 panels. I don't know if you guys can see here, right here, 15 panels. And each one of these panels, they have a location. This is my panel schedule, the location for each one of these panels. They have the circuit breaker, the main, and the size. They have, it's hard to see, it's voltage rating here. They have a number of circuits. They have the rating of each circuit, the number of poles, and what does it do for living? Is it protecting light or protecting receptacles? And I'll go over this one later on in a nicer format. So they have 15 panels in this project. Adam, all the 15 panels are located right in the perimeter. I don't know if you guys can see in here. Right here on the perimeter of this manufacturing floor, they have these 15 panels at 208 distribute the receptacle, feed the receptacles, and the light. Okay, a few things. We talked about this one article before, guys, and we'll be using it more often. Article 480 talk about the panels, and it says very simple. It says if you have a panel, and the panel is rated for 225 amp, it has to be rated to handle the load. You know, you can't have the load more than what the panel can handle, right? So your panel have to be sized based on Article 220 when you size your load. Karen, you guys have done this one, guys, for me last week when you size your panels based on the load. That's what this is. And also you have to have an overcome protection device right in the panel, right here. So this has to be a 225 amp or less. So you have to protect the panel with an overcome protection device that's equal to the amp of the panel or less, not more. So Adam, for a 225 amp panel, I cannot put 300 amp to protect it. It has to be 225 amp panels or less than 225 amp panels. Panels, guys, are rated. Panels through their circuit breakers, when they're carrying continuous duty, they are rated for 80%. What does that mean? When they have a 100 amp panel, this means load-wise, the load that I can pull continuous load, only 80 amps out of this continuous. If you have a 100 amp panel and continuous load like lights, you can only pull 100 amp out of 80 amps out of 100 amp panel based on the 80% rating, unless they are 100% rated equipment. Panel sizes, guys, I have the Walt Video has all the sizes, but they typically 100, 225, 400, 600, 800, 1200. I'll show you what Collar Hammer showed them in a second here. They don't have really, for the most part, they have a certain standards like the overcome protection device, but we have more sizes of overcome protection device than panels. You can install them without main, as long as you have the overcap protection device outside. So you have to have a circuit. Look at this one. This is a main lugs only, Adam. And this, where's the main for this circuit breaker? Somewhere else, right? Main lugs only. So that's your panel. You can tap the panel, guys. Look at this feeder. I can have a feeder here, gentlemen, coming in here. And my feeder, let's just say this feeder was 600 amp feeder. I can tab from this feeder in here and feed this panel and have 225 amp panel here through a junction box. And I can come over here, guys, through this connection and keep moving. So this is, and put another, can you see that? Another 225 amp and keep going to a third 225 amp, and as much as the feeder can handle. So you can take a feeder through a junction box or through, this is feed through, this is not feed through, this is sub-feed, they call it. Through a sub-feed arrangement here, you can feed the panel, go to the second panel. That's one way, guys, of saving some money in the field, where you can have one feeder, tap that feeder to multiple locations. Obviously, there are rules for tapping when you go from here to here, so you have to stay within either the 10-foot rule or the 25 feet rule tap when you tap that feeder. We're not using the tabs. When you're tying two cables carrying to each other, the lugs have to be rated for that. Can you guys see that? Here's how you tap a feeder. You know, you get the insulation out and then you take your tab. Here's another way of tapping that feeder to another lug. Or here's a main lug, and a third way of tapping that feeder, coming in, coming out, sub-feed. So these are ways, physical, mechanical ways of tapping a feeder or cable connectors. Circuit breaker, Adam, they can come as a single pole like this, or they can come as a double pole like this, or they can come as a 3-pole like this. These are all the circuit breaker, and you guys are very familiar with that one. Single pole, 2-pole, or 3-pole circuit breakers. You have to, when you purchase the panel, Adam, you have to specify the interior of these panels, the total number of poles you have, and the type of the poles. How many 20 amp single pole, and how many 30 amps or 20 amps 2-pole, and how many 50 amps or 40 amps 20 a single pole, 2-pole, or 3-pole. And then you separately order your circuit breaker. Sometimes major manufacturers, contractor guys, they have the whole chassis built in the factory. They tell them that directory, and they build all these circuit breakers for you. They build all these circuit breakers for you. Okay, so that's just a few things I'll show you guys. How do you select the circuit breakers inside as a branch circuit or a feeder inside the panel? You select them. So I have a 20 amp circuit breaker right here to provide overload for the circuit, so we can put our lights on this one, right? Ensure suitable voltage rating, so you don't want to have a lot of voltage drop here in the circuit. You don't want to have a lot of voltage drop in your circuit. Sufficient interrupting rating, so I'm going to make this one 10,000 amp to interrupt the short circuit 10,000 amp. Provide the short circuit protection, which is part of my sufficient interrupt rating, sufficient load or short circuit. And then you have to coordinate with other circuit breakers in the system. So if I have a 100 amp, 225 amp, I'm hoping that my circuit breaker here can trip before the main. That's your coordinated overcaptation device. Any comments, any questions? You made it?
Yeah, sorry.
Are you okay? I was trying to, I started graphing your sick days, and Friday start to look like a sick day for you. I was telling everybody, oh, I'm going to know when I'm going to be sick, though. Now, you proved me wrong, but that's good.
Sorry.
That's all right. Okay. Two rules should be followed whenever the magnetic trip. So when you put a circuit breaker like this, Adam, which 225 amp, and you need to set up the adjustable circuit breaker. You guys, Matt, you did the short circuit through SKM. When you set them up, here's the rule. I hope you guys will remember this one. The lower the settings, the greater the protection. The lower the setting of the circuit breaker, the greater the protection. Setting should be lower than value of the short circuit current available at that point. you should be able to handle the short circuit at that point. But the lower the settings, time-wise, time and current, the lower the setting on the time and the current, the more protection you have. What's the drawback? The drawback, ladies and gentlemen, is miscoordination. The drawback is miscoordination, nuisance tripping. Nuisance tripping. Derek, you have two types of panels. You can either have circuit breaker panel, you're looking at it right there, or you can have a fused switch panel. What's a fused switch? A fused switch is a fuse and a switch combo like this. So either I can have a circuit breaker that looks like this or a fused switch. Which one is better? You know, you can argue here. The advantage of circuit breaker, guys, is you can reset them if they trip for the most part, right? That's advantage versus fuses. If they open, what do you need to do? You're going to go unplug it, plug a new one. So that's advantage. The other advantage for circuit breaker panels is smaller in size. So this is circuit breaker. If it was a fuse switch, it will be twice as big as that. You know, so that's why fused switches are kind of, a lot of people use them in bigger amps like 1200 amp and higher on feeders because it's small. There's a little amount of fuses, but on distribution panels like these, there's a lot of circuit breakers here. If you want to put them as a fuse disconnect, the panel will be huge. Okay, so that's basically your fuse. Here's all your disconnect, and here's all your fuses that comes with it. With a fuse, a disconnect must come with a fuse. This is floor-mounted transformer supplying power panel. This is arrangement, Adam, my friend, in this building that we have. I'll go this one on the graphic. It's easier. So that's basically it. When you have a panel, guys, the panel typically will feed my lights as well as my power. My lights are easy. My power is divided into mechanical power. We have owner power. We have receptacle power. So these typically we have allocated circuits for the panels. You can have a circuit breaker panel or a fuse disconnect panel. A trip rating of circuit breaker cannot exceed the capacity of the bus bar. Like we said, if your bus bars are rated for 225 amp, you have to have a 225 amp circuit breaker or less. So that's all I'm going to show you. Let me just give me 1 second here to show you one other thing. So panels, guys, we talked about panels many times. So here's how they tab them. Very interesting. Save some money. We talked about fuse disconnects. This is just an arrangement that they're having, guys. I don't know if you look at, starting with A, they have a bus duct, Adam, like we did yesterday. Look at this. A bus duct, that's my bus duct, the feeder busway. Cable tab, this box, they're tabbing that feeder through the, they call it cable tab box, and then going to see primary fuse switch. Then they came over here to a fuse switch that feed the transformer. Then they went all the way to E, which is a panel. E is a power panel right here. From the transformer, we went into a panel, right? Into a panel. That's my E. D is the transformer, like I said. D is a transformer, primary. Power panel. Motor controller is F. They have a bunch of motor controllers also coming out of this, these Fs. We have I is a wireway that feeding these motor controllers coming directly and going somewhere. Secondary feeder protection is H. That's secondary of the transformer, and wireway is that little deal here. So what they're having, they're bringing power here, guys, tapping that power into a transformer. From the transformer, they're protecting primary, secondary, coming from a transformer into a panel. Out of that panel, they're taking a couple of motor controllers and feeding multiple motors. So this is where is this happening? Happening right into this project. Like you said yesterday, guys, if you walked into that plant yesterday and you were not confused or you weren't paying attention, there's so much. I mean, the power system, you can design it in so many ways. The best way, obviously, to understand it is to be part of the team that designed it. So that's why, and look at the risers and what's not. Here's how your panels look like, my friends, and you guys have seen many of them. Different type of connections. Single pole circuit breaker, 2-pole circuit breaker, 3-pole circuit breaker. You guys are familiar with them. Different sizes. Adjustable circuit breaker, Adam, right here. You can see, you can dial these to adjust them. Typically after 600 amp and 500 amp becomes adjustable. Power circuit breakers or fuse circuit breakers, look at that, it's big and bulky because the fuse
You have to put a few circuit breakers yesterday. And this is all basically the panel schedule that they have. Panel 1 located in the basement, north corridor. The main breaker for it is 100 amp. The voltage 28123 phase 4 wire. There are 19 circuit breakers, 20 amps each, single pole. 2 circuit breakers, 20 amps, 2 pole, and 5 circuit breakers, 20 amps, single pole, spare, and lighting and receptacles. Basically, these are lighting and these are receptacles. So they are identify how many circuit breakers and what they're doing. If you guys look all the way to 5, P15, there are 100 amp 5 circuit breakers. Each one of them is 100 amp, and it's tied to the trolley busway and the elevator. So they're feeding the trolley busway and the elevator. Look at this one, has 3 circuit breakers, 150 amp. Are these the circuit breakers? Yeah, number of circuits. 3 circuits. Each one of them is feeding the chillers. Anyway, so that's the panel schedule for all the panels that they have in this project. I want to show you guys color hammer, like we did. If you go to color hammer, Adam, which you should, we will for your friend Chad. Here's their panel board. If you guys go to Power R line 1A, this is the panel board. The most important thing it give you, this is a 240 volt max, so it give you 28120. And it goes lugs up to 400 amp and circuit breaker up to 400 amp. This panel, Adam, you're going to be using it for your lighting and receptacle panel in our project. That's your cut sheet. You're looking at it. Okay, and it gives you a couple of other things in between. If you guys go to 2A, it goes all the way to 480. Now you can power 480. The lighting panel, our lighting panel is going to be 480. And circuit breakers and lugs, both of them can go up to 400 amp. That panel, Adam, is going to be your panel for your receptacle, for your lighting panel. Lighting. When they say cut sheet for lighting, you're going to be bringing this one for your friend Chad. Okay? These are all directly guys from Color Hammer. If you go to the 3, look at that, getting bigger. Now I can go up to 600 amp, right? And look at the amps. The amps are going lugs 800, max 600. Now this will be part of your mechanical panel. Your mechanical panel is going to be Power R line 3A because the amps went up. So I need a bigger panel. Does that make sense, guys? These panels. And what happened if you need more amps? It keeps going up. Their last one is E. This can go up to, look at this. Oh, we were looking at that, didn't we? That 1200 amp. And if I go to 4, let me go 4 is the largest. 4, I can go, look at the voltages. It covers every voltage that God created, and it can go up to, can you guys see that? 1200 amp. These panels, Adam, are going to be your mechanical panels in our project. So I showed you guys this is the cut sheets that you can get. It gives you a lot of details, obviously, the circuit breakers. Look at the type of feed, breaker frame size, and breaker type, and interrupting rating, and different voltages. It gets a little bit involved. Ladies and gentlemen, any comments, any questions, guys, about panels and circuit breakers? That's it. So your panels typically, guys, up to 1200 amp. After that, you will start calling them switch gears and switch boards that they can go all the way up to typically 4000 amp. Any comments, gentlemen and ladies and gentlemen, any questions? So these, I can't emphasize, when I ask you guys for cut sheets and you say, Adam, here's your cut sheets ready. Always pay attention when you're doing with a cut sheet. I can't emphasize, this is probably the most important thing in the cut sheets. So if the voltage is 480 up, here's my 480. What's the amps? This can give you, look at the amps. Main lugs only, it gives you all these ranges. Main circuit breaker, all your ranges. So if my panel, if this is a 480 amp and I need a 600 amp circuit breaker, right? Here you go. Is it within that range? Yep. Main lugs or circuit breaker. Here's your panel. Any comments, ladies and gentlemen? Any questions? Comments, questions? We will have a speaker, guys, talk about panels too. Square D is coming and they'll talk about their product. This is Color Hammer, obviously Square D, Siemens, GE, and Color Hammer, the main manufacturer of panels and busways too. Any comments, any questions? That will conclude my lecture for the day. You caught the rest of it, buddy. I tortured you a little bit. So the rest of the day, guys, I hope you will dedicate to, we have from now until noon, so 3 hours. So please, let's hit the low voltage, get that sucker done. and I'll be able to help you here. Anything that you're missing, what's not. Look at the stuff, Adam, you were sharing with them, right? The stuff, the project that we already did. Please look at it. Look how it's laid out. Remember, it's not perfect. You have to look at the specification always. So, thank you.